Okay, these are the notes for 6.5, talking about indirect proofs and inequalities in one triangles. We're going to learn these three key elements over here. We're going to learn about indirect proofs. Writing indirect proofs, we're going to list the sides and angles of a triangle in order by size. We're also going to learn about the triangle inequality theorem. Okay, the first thing we talked about is talking about an indirect proof. Indirect proofs are a little bit different than the proofs that we are used to writing. Indirect proofs are proofs by contradiction. A contradiction is like proving something false. Okay, these are the 3 steps for doing an indirect proof. Let's go over a really quick example of an indirect proof. It says right here, write an indirect proof that in a given triangle there can be at most one right angle. Okay, here is our given that we have triangle ABC. Here's triangle ABC. And we need to prove that triangle ABC can have at most just one right angle. Okay, we're going to go by these steps that they gave us up here. And the first step says, identify the statement that you want to prove. And we're going to assume temporarily that this statement is false. So, what are we trying to prove? We're trying to prove that triangle ABC can have at most one right angle. If we're going to prove this by saying this statement is false, we're going to assume that the opposite is true. Okay, if we do that, what we're basically saying is we can go ahead and say that instead of at most one right angle, we can say that triangle, that ABC can have 2 right angles. So we can say that they can have 2 right angles, if that's the case, because we are going to go ahead and do the statement as false. Okay, let's go and think about this. In a triangle, every triangle has a total of how many degrees when we add up all of our angles? Our total will always equal 180 degrees. If we really had 2 right angles in there, right angles are 90 degrees. That would be the same as saying 90 for my one right angle, and we have 2 of them, so 90 plus 90 would be how many degrees total? That would give us 180 degrees total. We have 3 angles in every triangle. This is angle 1 and angle 2. We have to have 3. So then if this is already 180 degrees, and over here our total must be 180 degrees, we would be saying that the third angle would be 0 degrees. Well, we know that we cannot have an angle in a triangle that is 0 degrees. So we just reason logically until we reach the contradiction, and the contradiction is that we cannot have a 0 degree angle in any triangle. So this right here must be true, that we can only have one right angle in any triangle, because having 2 would make a 0 degree angle. So we're kind of going backwards and proving this statement false in order to get to the proof. Okay, the next thing we're going to talk about, we're talking about angles and sides of triangles. You've got to realize that the angles relate to their opposite sides. Angles and sides relate to each other in triangles. Okay, let's look at our picture. This right here, this says this is our largest angle, and it is directly across from our longest side. They're always going to relate with each other, and they'll always be directly across. So over here, when we look at our next triangle, this is the smallest angle, And if we go directly diagonal across from that smallest angle, we would have the shortest side. They relate to each other. Let's practice with this. We have two theorems that practice with that concept and that idea and that use it. One of them is triangle longer side theorem. And it says if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Remember, angles relate to the sides that are opposite. So if I look at this 8 right here, the angle that that side would go with would be directly opposite. So it actually goes with angle C. The length of 8 goes with angle C. Now, let's go over here and look at the side where the length is 5. This side right here is 5. It is directly across from angle A right there. So the side where the length is 5 goes with angle A, and the side where the length is 8 goes with angle C. Let's think about this. Which one's bigger, the 8 or the 5? The 8 is a bigger number. So if the 8 is a bigger number, that would mean that side AB is greater than side BC. And we know that because 8 is greater than 5. So that works with our sides. Now let's think about our angles in the same concept. Which one goes with our 8? That would be angle C. And we know that the 8 is larger, so angle C would be greater than, which one goes with our 5? Angle A. If this talks about the sides, then we're going to go talk about it in terms of the angles over here. So the triangle larger angle theorem. If one angle of the triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Okay, let's look at this right here. We're talking about angle A is 50 degrees, and over here we're talking about angle C is 30 degrees. I just marked through that. I'm so sorry. Angle C is 30 degrees. Which one's bigger? Is the 50 degrees larger or the 30 degrees larger? Well, of course, the 50 degrees is larger. So we can say that angle A would be greater than angle C. Okay, and since they relate to each other, the ones that are opposite relate to each other. Let's go see what is opposite angle A. Here is my angle A. The side that is opposite angle A would be side BC. And over here, the one that is opposite angle C, the sides opposite angle C would be side AB. They relate to each other, so looking at this, we know the 50-degree angle is larger than the 30-degree angle. And the angle A is relating to BC. So BC, side BC, would be greater than side AB. Because we know that 50 degrees is larger than 30 degrees. Looking at these, let's practice. List the angles of this triangle in order from smallest to largest. We don't know what the angle measurements are, but since sides and angles relate to each other, let's go ahead and mark side BC right here. BC is directly across from angle A. It would go with angle A. Okay, and then let's go over here. We know that side BA is 13, and it is directly across from angle C, so we know that side BA goes with angle C. Then we have side CA. It is 12. It is directly across from angle B, so it goes with angle B. So if we want to go from in order from smallest to largest. Let's think smallest. Which one's the smallest side? Of course, it's the side that is the 11. The 11 is our smallest side. And what angle does the 11 go with? It goes with angle A. If we go from smallest to largest, next. After 11, we have 12. 12 goes with angle B, so it would be our next largest. And then we have side length BA is 13, and it goes with angle C. So this would be writing them in order from smallest to largest. Okay, list the sides of triangle ABC in order from, now we want shortest to longest, and we're talking about the side lengths. We're going to do the same thing. We know our angles over here relate to the side. This right here is angle A is 59 degrees. Angle A is 59 degrees, and it would go with which side? Which one's directly across from it? It would go with side BC. Then we also know that angle B is 61 degrees, and it goes with side AC. Do we know the measure of angle C? No, but can we figure out the measure of angle C? Sure. All triangles have a total of 180 degrees. Okay, so you need to go and figure out what would be the measure of angle C. And this is one that I'm going to go ahead and let you work on to finish. We want shortest to longest. You need to go find out the measure of angle C. And we know that whatever that number is, it would go with BA. But it is one that you're going to go ahead and practice on. Let's go look at our next concept. Looking at this picture, what it's really trying to tell us is we can't just use any three lengths to make a triangle. We can't just pick random numbers and try and make a triangle. Because if you notice, is there any way at all that this yellow leg right here can reach this point in order to close that in and make a triangle? There's no way. It's too short. So we have a theorem that talks about that. It's called the triangle inequality theorem. Okay? This one reminds me kind of like when you were in elementary school and you went to go get a drink of water after PE. You all got in a line, and the first person went and got their drink of water. And after that person got their drink of water, they went to the end of the line. This is kind of one of those things, and I'm going to show you why that reminds me of getting a drink of water in elementary. This tells us right here, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, in other words, we're talking about side AB. Side AB right here. I'm going to add it to side BC. When I add those two sides together, it must be greater than AC. Then we're going to go ahead and do the next one. It moves AC back to the front of the line, and AC is now going to go to the front of the line over here, and our AB is going to go to the end of the line, just like you would when you were getting a drink of water. So, looking at this, now we have AC plus, well, there we go, AC plus BC has to be greater than the AB. If that statement's true, then we're going to go try the last one. Last one tells us, and if you noticed, AC is going to go to the end of the line, just like it did there over here, and then we're bringing up our what? AB moves along. And it doesn't look like it in the picture, but when I go do the examples, it will make a little bit more sense. Okay, so we're going to decide whether it is possible to construct a triangle with these three measurements, with those three side lengths. So, 4 is at the front of our line. I'm going to say 4 plus 9 has to be greater than 10. Is that true? Is 4 plus 9 greater than 10? Sure it is, because 4 plus 9 is 13. 13 is greater than 10. That one works. Okay, the next one. When I say go to the end of the line, 4 is going to go to the end of the line here, and 9 is going to go to the beginning. So I'm going to pull that up. 9 plus 10. 4 went to the end. Has to be greater than 4. Is that true? Well, of course it's true, because this is 19, and 19 is greater than 4. Okay, we're going to move 9 to the end and bring the 10 up. So now we have 10 plus 4. Is that greater than 9? Sure, because that is 14, and 14 is greater than 9. So if all three of these work, then yes, those measurements right there would make a triangle. Let's go try the other one. Okay, looking at our other one, we have 8, 9, and 18. Let's go ahead and start it. We have 8 plus 9. Has to be greater than 18. What is 8 plus 9? 8 plus 9 is 17. Is 17 greater than 18? No, it is not. If any one of these do not work, then it will not make a triangle. All three of them have to work in order for it to make a triangle. And since this one doesn't work, then those measurements right there would not make a triangle. Okay, last example, last thing we're going to talk about. A triangle has one side length of 14 and another side length of 9. Describe the possible lengths of the third side. Okay, go ahead, and since they've only given us the measurements for 2 sides, we know that we need 3 sides. Go ahead and pretend like the other side that we don't know is x. And we're going to do a small value, and then we're going to do a large. So let's go do the small value first. When I say small value, what we're going to go over here and do is, if I go ahead and subtract for small, 14 minus 9 is going to give us what? 5. Okay, so over here, we know that x has to be greater than 5, and that's working with the small side. Then over here on our large side, instead of subtracting it, we're going to take those two numbers and add those two numbers. If we add those two numbers together, we get 23. Okay, so then x must be less than 23. So if I go look at these over here, I have x is greater than 5, but it has to be less than 23. So we could go ahead and write it as, we can pick any number that is greater than 5 but less than 23, any one of those numbers, and put it with the 14 and 9, and it would work to make a triangle. Woo! We're done.